Hello, and welcome to lesson 1 of week 10, where we are going to look at graphs and how to interpret them. So by the end of this lesson, I'm hoping that you'll be able to analyze, interpret, and sketch graphs from a variety of situations. So let's talk about what is needed for a graph. Well, first of all, a graph illustrates the relationship between two variables. There's some information that you're going to find, and you should include in all of your graphs. First is the title. It tells you what the graph is about. It is important. Second is labels across the side and bottom that define the variables. So those are going to be words, and you're going to have numbers. Then you have starting values, which is kind of talking about the numbers that I was just talking about, and a line that indicates what is changing and how is it changing. So graphs can be discrete or continuous. We're used to pretty continuous graphs, but there is a difference. And this first one, the discrete graphs, if you look at those, it's like the cost and the tickets. What that means is that the information between the 2 points doesn't make any sense. So one ticket may cost $5, 2 tickets, $10, but you can't have 1.5 tickets. So there's no information between those 2 points. Whereas in continuous graphs, like this volume over time, so let's say we're turning down the volume on our radio, it's a knob a lot of times, or a button that you push, and the volume is going down. It doesn't go down a little bit per second, it goes down continuously. Okay. Also with graphs, you have rate of change. So the rate of change could be constant, like you see here on the first graph. It goes up by the same amount over time. Or it could be a not constant rate of change, where like this one, it starts out really fast, but then it slows down as you go. Or you could have a graph where there's no rate of change at all, where it stays flat. So what we're going to do now is we're going to take a look at a video. And I want you to watch this person as he climbs up the ladder and goes down the slide, and pay particular attention to his height of his waist above the ground. So you see here there's a title and the label on the y-axis, height of waist off the ground. The x-axis is time. Watch his waist above the ground. Now we're going to watch it slower and see if you can graph the height of his waist above the ground as he's going up and then down the slide. We're going to try and graph that. So I'm going to give you a second to pause this. Try to graph that. Hopefully you paused it. And this is you should have something that looks a little bit like this. So he starts his waist is probably about 3 feet above the ground. Okay. And he starts moving and he starts to climb up the ladder. And that's what you're seeing here is the increase in the graph. And then he's walking across. And this right here, a lot of people think he starts going down the slide. He does not. He sits down. His waist, as he's walking across the slide top, he sits down, and that's his waist going down to the top of the slide. And if you watch while he's doing that, he sits there for a little bit. And his waist, his height above the ground doesn't change for about 3 seconds. And then he goes down the slide. And at the very end, when his feet hit the ground, he stands up and his waist is 3 feet above the ground. And that's how that graph got interpreted. Okay. So we talked about increasing, decreasing, and no change there. And in that example, an increasing function is one that grows over a certain interval. A decreasing function is one that's going down over a certain interval, and a constant function stays the same. Okay, so we're going to take one more example here, and we're going to look at this person's commute home. So you've got total distance and time are your 2 labels. What does the 0 or starting point represent in this problem? Well, 0 time has passed and 0 distance traveled from the start, wherever that starting point might be. We don't know where it is, but the starting point, I'm assuming probably work since it's a commute home. So 0 time has passed and no distance has been covered. What are the units across the bottom? Time. But do we know what type of time? Is it hours? Is it minutes? Is it days? We don't know. The commute home could be a very long commute home. It's probably more in the realm of minutes or hours, but probably not days, but we don't know, and that's okay. As we move to the right, what is changing? So as you move to the right in this picture or in this graph, what's changing is the time. What are the units going up? Well, that's the total distance from the starting point. Now, again, it doesn't give you the units, but I'm going to assume we're talking miles. It could be feet, but probably not. Using context, it's probably miles, but we don't know, and that's okay again. As we move up or down, what is changing? Well, that would be the distance from the starting point. So we're going to take a look at riding a bus. Let's say we're riding the bus home, okay? A is riding on a bus, B is waiting for the bus, C is walking home, and D is walking to the bus stop. Pause the video and see if you can label those 4 points on the graph. So hopefully you gave that a shot. Riding on a bus, it's probably right there. It's where it's an increasing portion of the graph, and it's going a little faster than this increasing portion. All right, so B would be waiting for the bus. C would be walking home, and you see it on the graph there. And D is walking to the bus stop. So you leave work and you walk to the bus stop. You're not going to walk as fast as riding on a bus. Then you're going to sit there and wait for the bus to come. So that means your total distance is not changing. Then you're going to get on the bus and you're going to travel some distance. You're going to get off the bus and you're going to walk the rest of the way home, probably slower than you did when you were riding the bus. All right, well, that concludes lesson 1 of week 10. And you'll be moving on to your Math Excel now.